following techniques can be used to mitigate these security threats: using TCP intercepts to address DOS, TCP, SYN attacks, filtering ICMP messages inbound, filtering ICMP messages outbound, filtering traceroute. You can even employ ACLs for situations that don't necessarily involve blocking packets, like using them to control which networks will and won't be advertised by dynamic routing protocols. The way you configure your ACL to do that is the same. You just apply it to a routing table instead of an interface. The only difference here is that an ACL applied to a protocol is referred to as a distribution list, and it doesn't stop routing advertisements, it just controls their content. You can also use ACLs to categorize and queue packets for applications that require quality of service QoS, and for controlling the types of traffic that can activate a pricey backup link. So how do you go about creating an ACL? Well, it's really a lot like programming a series of if-then statements. If a given condition is met, then a specific action happens, but if that explicit condition isn't met, nothing happens except that the next statement in the list is evaluated. Access list statements are basically packet filters that packets are compared against, categorized by, and then acted on accordingly as directed. Once your list is built, it can be applied to either inbound or outbound traffic on any interface, causing the router to analyze every packet crossing that interface in the specific direction and take the appropriate action. There are a few important rules by which packets are processed when being compared with an ACL. They're always compared with each line of the ACL in sequential order, always beginning with the first line and then proceeding to line 2, then line 3, and so on. They'll be compared with subsequent lines of the list until a match is made. Once the packet matches a condition on a line of the ACL, the packet is acted upon and no further comparisons take place. There is an implicit deny at the end of each ACL that says if that packet doesn't match the condition of any of the lines in the ACL, it'll be discarded. Each of these rules has some powerful implications for filtering IP packets with ACLs, which is why creating effective ACLs truly takes some practice. There are two main types of ACLs. Standard ACLs, these use only the source IP address in IP packet as the condition test, so that all decisions regarding any packet will be used on the source IP address. This means that standard ACLs basically permit or deny an entire suite of protocols without distinguishing between any of the myriad types of IP traffic like web, telnet, UDP, and so on. Extended ACLs. Extended ACLs go the distance and evaluate lots of the other fields in the layer 3 and 4 headers of an IP packet. They can evaluate source and destination IP address, the protocol field in the network layer header, and the port number at the transport layer header. This gives extended ACLs the ability to enforce highly specific network traffic control conditions. Once you create an ACL, it doesn't do much of anything until you apply it. Yes, it's there on the router, but it's inactive until you tell the router what to do with it. To use an ACL as a packet filter, you've got to apply it to the interface on the router exactly where you want the traffic filtered, and you've also got to specify the traffic's direction, inbound and outbound. This is because you probably want different controls in place for traffic leaving your network that's destined for the internet, that you want for traffic coming into your network from the internet. Here's the difference. Inbound ACLs. When an ACL is applied to inbound packets on an interface, those packets are processed through the ACL before being routed to the outbound interface. Any packets that are denied won't be routed because they'll be discarded before the routing process is completed. Outbound ACLs. When an ACL is applied to outbound packets on an interface, those packets are routed to the outbound interface and then processed through the ACL before being queued. Creating ACLs is great, but don't forget to apply them to an interface or they're not going to filter traffic. With that in mind, here's a list of rules to live by when configuring ACLs on interfaces from the internet into your production network. Deny any address from your internal networks. Deny any local host address 127.0.0.0/8. Deny any reserved private IP addresses. Deny any addresses in the IP multicast range 244.0.0.04/4. These addresses should never ever be allowed to enter your network. Port security. While firewalls can be used to protect access to the network at layer 3 IP addresses, there are cases where security needs to be maintained between users within the network. This can be done by implementing port security on the switches in the network. When you do this, you are enforcing security at layer 2 MAC address. This can be done in several ways. First, you can use port security to define a set of MAC addresses that are allowed to access a port where a sensitive device is located. Another use is to set unused ports to be available to only a pre-configured set of MAC addresses. The second example could help to prevent unauthorized persons from plugging into a wall outlet, connect to a secured switchboard and accessing the network. Demilitarized zone. Most firewalls in use today implement something called a demilitarized zone, which, as its name implies, is a network segment that isn't public or local but halfway between the two. People outside your network primarily access your web servers, file transfer protocol FTP servers and mail relay servers, and because bad guys tend to go after these servers first, it's a good idea to place them in the DMZ. A standard DMZ setup typically, but not always, has 2 or 3 network cards in the firewall computer. The second goes to the first one goes to the internet. The second one goes to the network segment where the commonly target server exists. The servers I recommend to be placed in the DMZ, and third connects to your internet. So I'm going to leave it here today for this video. If you like listening, please consider like, share and subscribing. Thank you.